Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hello, everybody. Welcome to a brand new episode of the Clear to Send podcast. My name is Roel Dionisio, alongside with our co-host, Francois Verges. How are you doing, Francois?
I'm very good. How are you, Roel?
I'm doing very well. We're doing this where I'm up super early, but I guess you're up a little early because you're in the United States this time, right?
Yes, Central Time. So I'm only 2 hours ahead of you. So
all right.
It's still early here.
It's still early,
nice.
Right? So we're trying to get this episode out to you guys, and in this episode we're gonna do a short, educational episode where we talk about wireless WLAN service sets, and it's part of the objectives for the CWNA to know what service sets are, and I think it's a great idea to go over them and do an overview of what the different service sets are. And so in the 802.11 standard, there are different topologies that are defined in there, and the 802.11 radios are used to communicate with each other, the clients. And so a lot of us are familiar with the most common service sets, which is BSS, your basic service set, and also maybe an ESS, your extended service set. But there are other ones that a client can operate in, such as the independent service set, your personal basic service set, mesh, and QoS. So we're going to go through some of those, starting with the basic service set, because that is the the foundation of a WLAN. It's the most common 802.11 topology.
It's also the simpler one, so you can start from there, to explain the other ones.
Yeah, and it's really a BSS, or basic service set, is a 1 AP with one or more clients that associate with it.
Yeah, that's a definition from the standard, pretty much.
Yeah, and this one's really easy to understand, and from this basic service set, you have your SSID that your access point is broadcasting, and those SSIDs, it could be multiple, will have a unique basic service set ID, and this BSS ID is a MAC address from the AP's radio of that SSID, right? And that's advertised in the beacons, and you can see that if you do a Wireshark frame capture, and we can add a screenshot of what that looks like if you don't know. But this is how a client knows which SSID to join and from which radio.
So the BSS is pretty much one AP and one or more client associated to it. To be more precise, we should say, instead of saying one AP, we should say one radio and one or more client associated to it, because it was one AP. Most of the times you have multiple radios, like a dual band AP, you'll have two radios, 1, 2.4, 1, 5. So in one dual band AP, you'll have essentially two basic service set, one BSS for the 2.4 radio, another service set for the 5 gig radio. And the way I usually put it is, okay, we have the BSS, which is one radio with one or multiple clients associated to it. How do you identify the BSS? You do it through the BSS ID. Okay, and what is the BSS ID? Like you said, it's a MAC address of the radio itself, right? And it will be used, like you said, in the frames sent by the AP, especially the beacon frames. The BSS ID will pretty much be the source MAC address of the beacon frame.
Yeah, and the standard references BSS in different ways, where you have your different technologies, right? You have your high throughput BSS, or your very high throughput, and the new one that we're waiting for will be your high efficiency 802.11ax BSS. And the BSS itself, when coming from the AP's radio, it forms what is called a basic service area, or BSA. And the BSA is where you have your clients in a BSA, and as they roam between access points, they move between these BSAs, and they're going to negotiate, your rates dynamically. As the RSSI changes, as SNR changes, as the environment changes, they'll dynamically negotiate those data rates. But when you look at a BSA and you see images of this, and we'll have some images on the show notes, but one of the things you'll see is a circle, right? Because we're trying to visualize a basic service area. One of the things you should realize is that it's not a perfect circle, and there's no.
What? Are you serious?
It's not the outline of a red cup, but there's no sharp cutoff of a basic service area because of the different environments that affect that signal. You have your dry walls or your hallways, or maybe obstructions that change the shape of that service area.
Yeah, and plus, yeah, exactly. The signal doesn't create a perfect circle or coverage area.
And I think that's one thing people should realize. Even when they're designing networks, you're looking at you're creating your network, and you see that signal propagation. It shouldn't be creating this perfect circle. That if it is creating a perfect circle, that's just, I guess, that piece of software.
Pure coincidence.
Yeah. That it's either coincidence or that piece of software just isn't updated to reflect how signal will be propagated through the environment. So
Are you
what
talking
you're seeing,
about some NMS systems?
yeah. There's one in particular that likes to create perfect circles, and that's just not how the signal is. But that is your basic service area, where from that AP's radio, it creates that basic service set which clients join to based on the BSS ID. Do you want to add anything else to basic service set, Francois?
No. I guess one thing we can add is if you look at the Wi-Fi scanner, you should be able to be able to identify the different BSS, right? Most of them will give you one line per AP or one line per radio, like pretty much one line per BSS, and you should be able to identify the BSS ID, identifying this specific BSS. And I guess we can include a screenshot of Wi-Fi Explorer in the show notes, so you guys can know what I'm talking about.
Yeah, Wi-Fi Explorer is going to be the one application that both of us use often, and that will, like as Francois said, show you the different basic service sets in a nice to read, easy to read fashion. And that's just how you should think of it when you look at that list, the BSS IDs, and then their unique MAC addresses for those AP radios. All right, so the next service set that we have is the extended service set, which the extended service set is really multiple basic service sets that have the same SSID, and they're all connected to the same infrastructure. So you'd call that an extended service set. So an example would be me running my Wi-Fi for the entire campus. All those basic service sets coming from those APs are part of my extended service set. Would you agree, Francois?
Yeah, so all the APs are connected to the same distribution system. This is the term used in the standard. So if you see that DS in the standard, that's pretty much what it refers to. Most of the time, that's just our Ethernet network, layer 2 network. And your APs are cabled back to your LAN. So the LAN, I guess, would be the distribution system. And all these APs will be pretty much providing the same network, right? So if for your campus, you have the SSID SSID Stanford, like every, all the APs will be broadcasting the same SSID. And if you connect to this SSID, depending on the AP you connect to, you're going to be connecting to a different basic service set, but it will be included in the same extended service set, and you should be getting the same, connectivity, same IP addresses and so on. And you should also be able to roam between different basic service set included in this extended service set.
Right, and there will be, hopefully, if you roam, or when you roam, there's going to be some overlap of those basic service set areas, right? So because you want to create that handoff between the basic service sets, and hopefully you have what's called fast BSS or 802.11r to make that more efficient.
Yeah, it's common sense. It's a requirement. If you don't have overlap between your BSS, you're not gonna have proper roaming, right? So if you have like two buildings and one AP per building, and they might be in the same ESS, but if you have to walk outside, cross the road in order to go from one building to the other, you're not going to have proper roaming. You're going to disconnect and then reassociate to the next AP when you enter in the other building, right? So you need to have proper, when you do your design, you need to make sure you have proper I was going to say BSA overlap.
Right. We usually say cell overlap. We're using the acronyms that are coming from the standard, and so that's just what the standard calls it. And you'll probably see this in CWNP certification as well. But yeah, we usually call them cell overlap, but really it's BSS overlap or basic service area overlap, in order for clients to roam from one BSS to another.
Yes. So now, how do you identify an extended service set? Because it's different from a basic service set now, right? Basic service set, we use the MAC address of the radio to identify it. Now we're sharing the extended service set in between different APs. So the way we identify it, it's pretty much using the SSID. Yeah. Right, the common. Well, it's more precisely, it's a ESSID, right? Mm-hmm. Extended Service Set Identifier, but we usually call it the SSID, and it's not a MAC address anymore. It's just a name, a string, right? And that's how we identify the ESS, and that's the name that all APs will be sharing.
Yep. So that's your extended service set. And again, that's if you're running multiple APs that's connected to the same distributed system, and that becomes your ESS. Multiple BSSs using the same SSID, and there you go, ESS.
So now it gets tricky, right?
All right.
Yeah, let's bring the level of complexity up a notch. So in typical environments, right? Let's say you are at work, you have an AP, a dual band AP, one 2.4 radio, one 5 gig radio. How many BSS do you have under that AP?
Oh man.
So right now, if you're only broadcasting one SSID, you should have two BSS, right? One BSS for the 2.4 radio, and then a second BSS for the 5 gig radio. Now, what if you have three SSIDs? How many BSS do you have under that AP?
One for each radio.
One for each SSID for each radio.
Yeah. So when you look at my mind is blank because it's so early in the morning, but Wi-Fi Explorer, right? So if you look in your environment and you have, say, more than one SSID broadcasting from an AP, you will have to expand. Like if you organize it by MAC address, you can see that there's different BSSIDs for the various SSIDs that you have. So if you have three, you'll see one for each SSID will have a BSSID for each radio. So you should have six.
Exactly. So you should have six, three on the 2.4 and then three on the 5 gigs. That's if you're broadcasting your SSIDs on both frequency bands. Okay, let's not change the complexity there. So now the question becomes, okay, we just said that to identify a BSS, I'm using the MAC address of the radio. Now that I have 3 BSS under the same radio, how do? I only have 1 MAC address for the radio. Right? So this is when you have, if you look at, like you said, Wi-Fi Explorer, if you do packet capture, you'll see that the AP will pretty much create BSS IDs, right? They will create, it's not fake MAC addresses, but it's virtual. Yeah, that's what I was looking for.
Virtual.
It's virtual MAC addresses that they will use as BSS IDs, so they can identify and differentiate different SSID under the same radio on one AP.
Yeah, and you'll see some APs reference that they can only have X number of SSIDs, or
usually,
so there's depending on the vendor, it just depends.
Yeah,
but
this is not defined in the standard. The process of creating those virtual BSS is not defined in the standard. So every vendor will have different way of doing things. Some vendor change the end of the MAC address. Some vendors change the OUI. Some vendors change, the middle bits or whatever, and they do it differently. So if you're just curious, you can just look on the Wi-Fi scanner how they do it, or you can do packet capture.
Yeah, and that's something is a little tricky sometimes with vendors, and hopefully it's just changing the end of the MAC address, and that's how you can identify a little bit easily which BSS ID is with which AP, because I look at if it's usually based off of the base MAC address, then you can tell. You can kind of see that that must be on the same AP, just those are the virtual MAC addresses of the radio. It's a little bit beyond what we're discussing here, but it's a good helpful tip just to see which SSIDs are with which AP, and you can organize that in Wi-Fi Explorer by if you just look at MAC addresses, you can see the similarities. Yeah,
because you'll pretty much see that in any environment, right? We nowadays we have APs with multiple radios and supporting multiple SSIDs.
All right, so now we're going to go into some of the service sets that I don't usually come across often just in my environment. I don't know if you come across these yourselves, Francois, but no. We'll talk about this one in particular. I have not seen because I don't do this often, but it's the independent basic service set. And there's going to be very few cases where you aren't connecting to, say, an extended service set. The independent basic service set is a really basic wireless network consisting of just 2 clients, or it could be multiple clients as well, but they're really connecting to each other and not to a distributed system.
Yeah, there's pretty much no AP. So when I talk about basic service sets, usually I start with independent, right? Independent, that's what we used to call ad hoc networks, right? There's no AP. You just one station to another station, you connect and then you exchange data. I think macOS used to support it back in the days. I remember using it at university to exchange files with my friends. I don't think it's used anymore. Maybe for AirDrop. That's what I wanted to double check. AirDrop, if you're not connected to any network, they will just set up a virtual a Wi-Fi network between your Apple devices, so you can exchange files faster than Bluetooth, pretty much. So I'm not sure if that's using IBSS. We could do, I guess, a packet capture and find out.
And I think Windows is still capable of creating an IBSS.
Okay.
I've seen that before, where you can create a separate internet connection, and then you could broadcast an SSID so devices can connect to your laptop. It might be different with Windows 10, but I know it was possible before.
Well, sometimes, with all those new systems, like even on your phone, when you do hotspot or when you share your data, or you use your phone as a hotspot, that's not an IBSS, that's a BSS, because your phone becomes the AP.
Right. It kind of seems like it's an IBSS, when you're doing that hotspot, it almost seems like an IBSS, right? Because you are using your client device, but
Yeah.
I guess it's a very smart device. It can have LTE as a backhaul, so and then turn into an AP. But yeah, I can see where some people could be confused because an IBSS is where there's no AP. It's just a client radio, and you're probably thinking, well, if my phone's not an AP, so it's probably an IBSS, right? But yeah, the BSS ID is generated by in an IBSS by the first station which sets up the IBSS.
Yeah, exactly. Since you don't have any AP that's there all the time, broadcasting in a society with a specific BSS, how do you identify the IBSS? So like you said, it's the first station that set up the network that will just, it's built in the standard that it's defined that way that they will randomly generate a BSS and that a BSS ID, and it looks like a MAC address, just like a BSS ID.
Yeah, and because in an IBSS, multiple clients can connect to each other, they create this direct connection with each other. And you might start thinking, well, wouldn't that be mesh? And it's not quite mesh because you're not using another client as a backhaul connection. You're just connecting directly to it, and it's not using a mesh protocol.
Yeah, and because everyone is sharing the same channel as well, like you can only have one station communicating at one given time. So even if you have more than two stations connected to the IBSS, only one will be talking at one given time.
Yep. All right. So the next service set, which I have actually used before, is the personal basic service set, and in the standard, it's similar to an IBSS, but this is for DMG or directional multi-gigabit. And where directional multi-gigabit is used is in the 60 gigahertz.
That's 1180.
Yeah, 802.11ad. And where you would use this are with point-to-point connections. Those are basically your millimeter wave devices. So things like having a backhaul connection between two buildings, that's where you would use this.
So you said you've used it before?
I have, yeah. I've set up a millimeter wave, 60 gigahertz. It is multi-gigabit, and it's really interesting technology if you ever get to use it, where you're creating this wireless link and you actually get full duplex. On the wireless link, and it's multi-gig. The one I was using was capable of going up to 5 gigabits per second. And wow. I know earlier last year, I think Q2, that same company released a 10 gigabit model. So 60 gigahertz is really interesting, where it creates this personal BSS. And what it is these radios will communicate directly with each other. One of them acts as this personal BSS control point, and through that PBSS, that's where you establish your connectivity. And again, it's used in 60 gigahertz. You can see this in the 802.11 standard as DMG, directional multi-gigabit.
Okay, and then one client will be the PBSS control point, the PCP, right?
Yeah.
Okay, so you set that up in the config, or is it the first one that comes online?
When you set it up in the configuration, it doesn't actually say which one will be your PBSS control point. You kind of set one up as it's like setting up any device. One of them you set up first, and then you tell it what's which. It's on the other end, what's the connection and what frequencies it's gonna see. They'll be pre-configured with the frequencies, and that's what makes it a lot easier to configure.
Okay.
All right, so we're down to the last two. Some of you guys may be familiar with this one if you're using mesh at home. It's or even in the workplace. I don't know, you might have to use mesh for some reason. It's the Mesh BSS, right? So the Mesh BSS is where all clients in an MBSS establish links with all the neighboring clients. And then from there, they determine their different hop capabilities, how they're going to hop between to get to like the backhaul, right? So I guess the best example I can give is in the home, because as we're recording this, CES is coming out with a bunch of brand new mesh APs. So you have an AP that connects to your to the wired infrastructure, right? To your wherever your wired connection is, and it can broadcast. It can create this MBSS to have another AP connect to it and use it as its that downstream AP can use it as its backhaul. And that downstream AP could also create another MBSS with another AP or service actual clients that connect to it.
Yeah. Yeah, so the mesh is, it wasn't actually part of the standard. They added it in the 2016 version. So before that, we only had IBSS, BSS, and ESS, and then they added the PBSS you talked about for 60 gig. They added the mesh BSS, and they also added the QoS BSS that we'll talk right after. But so they wanted to define in the standard the mesh, I guess, because every vendor had their own proprietary way of doing things.
Which
when you do
do
mesh, you also have to I don't know if it's called routing, but it's layer 2 routing, right? To make sure that the traffic goes back to the wired network at one point.
Yeah, and I guess in routing, it's really picking a path, like which mesh access point is it going to go through? Because it'll calculate the best path in the mesh link as it connects to different clients, which is the best path to get to the wired network.
Exactly, and this routing can get quite complex sometimes with some vendor. Well, they take like load into account, frequency and so on. So they I don't think they enforce that. They let the vendors use their proprietary protocols that they've been working on for years. But maybe they wanted to have a standard for all the new system we see, maybe for the home environment and so on.
Yeah, so I don't use mesh very often or at all. I think the only time I've used mesh was with a vendor called Open Mesh, which got acquired by some other company, but they were very big on doing mesh clients. And actually, Meraki, I think, started off that way, creating mesh. So that's MBSS. We don't have much to add to it other than it's another different basic service set, but dealing with mesh. And the 802.11 2016 standard has a lot of detail into how that can work. There's a big section on that. All right, the last section, Francois, how about you talk about QBSS?
So the last section is called QBSS, which is pretty much quality of service basic service set. So this is not very complex. It's just a basic service set that uses QoS, right? And if you look in the access point that have been manufactured in the last 10 years, they all support QoS, right? Sometimes it's transparent. It's enabled by default. They don't even let you choose it in the configuration. It's just there by default. Sometimes they let you enable it, tweak it, but it's been there for a long time now. So a QBSS is pretty much a BSS that uses QoS. That's pretty much what it is.
All right. So those are your basic service sets, and just quickly outline them again. You have your IBSS, Independent Basic Service Set, your BSS, Basic Service Set, ESS, Extended Service Set, PBSS, Personal Basic Service Set, MBSS, Mesh Basic Service Set, and QBSS, QoS Basic Service Set. So there you have it. Those are your WLAN service sets. Hopefully you guys got a good understanding or refresher on what service sets are, what's the difference between each of them, and how we actually deal with them on a day-to-day basis. We talked about how you could use Wi-Fi Explorer on the Mac to look at these service sets and how to organize them. And also, I may try to add in a screenshot from Windows. I know we give a lot of love for the Mac users, but I know we have some Windows users out there. So I'll try to find an application. I think I have one on my Windows laptop that I need to turn on. I haven't turned it on in a while. But there are apps on the Windows as well. There's also apps on Android. Any Wi-Fi scanner can show this to you as long as it's showing you the BSS IDs, for example, and you'll just look over our show notes and you'll see, okay, oh, there's a basic service set, and you'll start to understand what that means. Because with the Wi-Fi scanner, you probably won't see that it's a PBSS, for example, because that's 60 gigahertz, and our laptops are only 2.4 and 5 gigahertz.
I would also encourage you guys to do packet capture and look at the different addresses that you have in the 82.11 header and try to see if you can reference that back to a business ID. Maybe look at the also the where you can find the SSID in the header. And try to make the distinction between the BSSID and the ESSID.
Oh,
that's a good exercise. Yeah.
Cool. Well, that's our episode for today or this week, talking about WLAN service sets. If you have any questions, hit us up on Twitter at clear2send, or head over to the show notes, clear2send.net/156, where we will have a short bulleted list of what we just discussed. And likewise, if you guys have the time and you enjoyed this episode, please share it with anyone you know who could find this useful, and let us know what you think about the show by reviewing us on iTunes. Go to clear2send.net/iTunes. Other than that, we'll see you guys on the next episode. Thank you guys.
Thank you guys. Have a good week.